Welcome to part 3 of the wood lathe build. So let's plow on with the tool rest. Working with scrap metal can be a bit tricky sometimes. I like this wing knob style thing, and if it gets in the way I can use a regular bolt instead. And again I close the ends, even though I don't think it is strictly necessary, but it looks nicer. Definitely. Next comes the actual tool rest itself, this thing here, and it needs to be adjustable up and down, left and right. So in this direction, you want to be able to turn it, and therefore I want to weld a post onto here. In this case it's a 20mm threaded rod. Not ideal. I would prefer to have a M25, but I don't have an M25 on stock, so I hope the 20mm will do. And the tool rest will sit on a pipe which slides over this post, so I can turn it and move it up and down. Okay, let's go. So here is the, let's call it the post, welded onto the tool rest base. Now I can slide my pipe over, and on top of this pipe, shorter of course, will sit the actual tool rest. And again, I hope that makes sense. So I have cut off the post and pretty much finished the tool rest. And yes, the angle is fixed because I don't think I will ever have to change the angle. And now I can move the tool rest up and down, as well as turn it. Next I have to weld a nut onto this pipe and some kind of handle again. And this time, because I'm going for a M10 instead of a M12, I have used a coupling nut to give me more threads. Mickey Mouse, is it you? And again, if Mickey Mouse gets in the way for some reason, I can use a regular bolt instead. And of course, I made a much skinnier version to reach into tight spots or into bowls, for instance. Maybe I make more of them, who knows. And I think some parts are ready for the first coat of lacquer. I use an oil-based lacquer, so I don't need a primer. And yes, I want to paint this one as well as the tailstock and some other small stuff. Because I'm at it, here's a quick overview of the motor arrangement which I want to use for the lathe. I want to use a universal motor. It's a washing machine motor, 500 watt, 15,000 RPM. And to control the motor speed, I have bought a washing machine motor electronic of eBay. It is a closed loop system, which means it also uses the taco generator at the back to maintain a constant speed. And this electronic is based on the TDA 1085C, just in case if you want to Google that. The electronic cost me 30 euros. The motor did cost 15 euros, so pretty cheap arrangement here. And for adjusting the speed, I have here a simple potentiometer, and this way I don't need any gears or change belts whatsoever. Let's test it. It goes from nothing to full speed, 15,000, and no matter how hard I burden the motor, it maintains always the same RPM. Turn it off. So, pretty torquey. I think that's fine for the wood lathe. And yes, as I said, there will be a reverse switch. That's the reason why these wires here are connected together. So I want to have forward and reverse, as well as speed control via a knob. Yeah, that's for the motor. And now I have to wait for the belt to arrive, because I've ordered the wrong belt. So that's why I cannot start with the motor and drive configuration on the machine right now. This will be the belt pulley on the drive shaft. 2 discs of 16mm birch plywood. This gives me enough meat for the belt. So the next step is to glue them together and drill a hole and turn them. So here's my improvised setup. So let me quickly go through what I'm about to do here. I've attached a motor temporary to the machine here, and I turned the drive shaft by 180 degrees. So I have the pulley on this side. The pulley blank is already mounted to the pulley shaft, and this way I can turn my belt pulley directly on the machine. And just for curiosity, I want to see how fast this thing is spinning. Perfect. Here are the grub screws, pointy, and here are the two holes where the grub screws can grip into. I turned the shaft over, and now I can test it the right way around for the first time. So here is what it's supposed to look like in the end. Now it's a matter of waiting for the correct belt to arrive. So far so good. Next comes the base or the cart where the machine gets mounted onto, and it should look like this or something like this. So with wheels on one end and here are the wheels. For the legs, again, I'm using a damaged pallet rack beam. Here are the legs. Two of them are shorter because that's where I want to mount the wheels. Jeep Charlie. End caps are on, and now comes the main frame. My stock is prepared, so let's weld it. The frame is done, and now I can put on the legs. Let's weld the legs on. Schmatze! Nice, nice! The main structure of the machine cart is taking shape. Nothing fancier about that. It's basically a table frame thingy, and I've added wooden pads to the legs to protect my workshop floor. Next step is to mount the wheels onto the cart and connect the lathe somehow with the cart. And of course I need some kind of collapsible handles to wheel that thing around. And I'm drilling a little bit above the center line so that later the wheel axle is a little bit tilted. Perfect. And just in case you wonder, yes, I will use a threaded rod as a wheel axle because the wheels have roller bearings inside, and I know from experience that this solution works absolutely fine for many years, since I don't have in mind to roll this thing around very much. Welding. Yes. Now I need handles. Plasma cutting freehand is not the precisest method, but for this application it will have to. The hinges are on. Maybe not the most elegant design, but it works. It's looking good so far. And now let's find a way to connect the machine to the base. And I think I have to add 1 or 2 more struts in here. And why did I make it wider in the first place? Because I want to add a back plate here as a dust shroud, so the wood shavings stay contained inside this area here, and I don't have the wood turning shavings all over the place. And for the materials which I want to use to mount the machine to the base, I have some angle iron here and square tubing here. And since we are talking about 2mm wall thickness, it is maybe a good opportunity to test my cheap eBay riv nut tool here. Mate, that's fine. Okay, let's see. Pulling back this thing, insert the M8 tool, Zack, yeah, and nut on top. Okay, that's it. Reef nut. Let's press it in. Yeah, I think that's enough. Hey, not that bad actually. I like it. Perfect. And it took me just a couple of minutes to press all 4 riff nuts in. Why is it always such a mess? So everything is upside down now. That's how it looked from the bottom side. And now I will weld it here